Yes, folks, how are you going again? So we're continuing in our series where we're working with polynomials. All right, so we're talking here about the division of polynomials. So what I'm going to do is I'm going to illustrate the concept using polynomials that you're already familiar with, which is quadratic, a polynomial of degree 2, and the linear polynomial, which is a polynomial of degree 1. So let us say, for the sake of argument, and I'm going to use one of my favorite quadratics, we start simple, right? I like to start off by saying x minus 1 into x minus 2. This is a regular expansion. You have two linear terms being multiplied by each other, so you expect your answer to be a quadratic. All right? That will be x. Let me just run through it quick. X by x is x squared. X by minus 2 is minus 2x. X minus 1 by x is minus x. And minus 1 by minus 2 is plus 2, which will give you x squared minus 3x plus 2. So in other words, what we're saying is that x minus 1 into x minus 2 is equal to x squared minus 3x plus 2. Alright, so let us go back now to your basic numerals that you're familiar with. If 2 multiplied by 3 is 6, right? And I'm going to just use the, right? If 2, let me say that's 2, and let me say that's 3, you expect the answer to be 6. Not so? Yeah, that will be the answer. So if 2 by 3 is 6, we expect then that if we divide 6 by 3, we expect then that 6 divided by 3 is equal to 2. And we also expect that 6 divided by 2 is equal to 3. That is what we know. That is what we're familiar with. That is what we use every day. Sometimes we do it so instinctively that we're not even aware of that we're doing it. Yeah? So again, my method, anytime I could, is to go back to what you're familiar with and come up the road to illustrate the complex concepts. So in the same way that 2 by 3 is 6, implies that 6 divided by 3 is 2, and 6 divided by 2 is 3. The same concept applies with the complex situation here. And that is something that I want you to remember. Mathematics, essentially, a lot of mathematics is about the transferring of simple concepts into more complicated situations. So if 2 by 3 is 6, and 6 over 3 is 2, and 6 over 2 is 3, you don't expect it to be any different if you have x minus 1 by x minus 2 multiplying together to give you x squared minus 3x plus 2. It's the same thing. It's the same thing. So let me change the color of the ink now. So applying this logic, what this therefore will mean is that x squared minus 3x plus 2 divided by x minus 2 will be equal to x minus 1. Alright? And what it will also mean down here is that x squared minus 3x plus 2 divided by x minus 1 will be equal to x minus 2. Good? So you know that. You know that simply because you transfer the concept from regular integers that you're familiar with into a new situation that you might be a little unfamiliar with. So instead of dealing with integers as we have here, you're basically dealing with expressions now, and the expressions involve an unknown quantity which we denote by the letter x. Alright? So now my job, my task, especially for the people who now start in the add maths, is to demonstrate that this divided by this is this, and that this divided by this is that. Alright? So we're going to do the both of them now. I will round off this video with these, and then in the next video we'll go to a higher level where we're doing the same thing, but we will go past powers of 2 into powers of 3 and powers of 4. Alright, so let me clear some space on the board. Now, remember, did I bring the calculator or did I not bring the calculator? Hold on. No, I didn't bring the calculator, but we're recording, so we don't have the liberty of stopping now. Let me see if I could pull something out of the hat. Let us say 15 squared is 225. So 15 by 16 is 240. 15 by 17 is 255. All right, so let us, for the sake of argument, divide 255 by 17, right? Remember, again, we're going back to the foundation here now, right? Excuse, so we're saying that 255. See, I learned something here tonight. I was not aware that 255 could be divided by 70. Remember, back in, I think this is something that we would do in primary school. Right? This is something that you would do in primary school, where you have a long division, where you have, this is the divisor, right? This is the dividend, I think it is. And the answer you get here is the quotient, right? So I'm taking you straight back to what? Second year, standard 1, somewhere thereabouts, right? And again, I am just illustrating that even though we're at the level of add maths, we're taking concepts that you would have done in primary school and applying it to a much more complex situation. And that's all it is. That is all it is. So you're making the connection to things that you're already familiar with. And all of that to say that the thing not as out there as they might think it is, it just needed to take a little time and sit down quietly and focus on it. Alright? Yeah, watching the time here now. So these concepts will remain with us as we discuss the division of polynomials, and as we go into the whole issue of the remainder and factor theorem, which will come a little later, we'll be using the same concepts. Alright? So getting away from the vocabulary now, let us now deal with the essential issue of carrying out the multiplication. Right? So remember, in school, up to this point, you would say, alright, 17 into 25 is 1. Right? Now you know that 17 by 2 is 34. If you don't add math, you're supposed to know 17 by 2 is 34. Right? So if the number is less than 34, you know that the number on top here is 1. 1 by 17 is 17. Alright? Now, you're doing your subtraction here now. Let me see. 25 minus 17 is 8. Let me just leave it at that, because anything you do here will get the same thing. If I take 1 from this 2 and bring it up here, 15 minus 7 is 8. So I just minus them just like that. 25 by 7 minus 17 is 8. And again, if you're doing add maths, you're supposed to know that 25 minus 17 is 8. Right? I keep reminding you all that you're at a higher level now. Right? And as I would have mentioned in a video before, here is not the place to slap. The things you will get away with in maths, you will not get away with in add maths. Right? There are many people who get 1s in maths They come up to add maths and they get 3s and 4s. So don't take it for granted that because you're doing well in maths, it will just automatically follow that you'll do well in add maths. It's a thing. It's a gap between the two that you have to close. And the only way to close that gap is by application and work, you know, a certain mentality, a certain attitude. Right, so now I pick up this marker here now. Right? So 25 minus 17 is 8, and then I bring down the 5. Right? And then of course 17 into 85 is 5. 5 by 17 is 85. And you have no remainder at the bottom here. This is an example of long division. Now I deliberately use a kind of smallish number because I didn't have the calculator in hand and I didn't want to stop the recording to go and get it. Right? Of course, we could do the same thing with longer numbers. So if this was 2550, for example, then the answer up here will be 150, etc., etc., etc. Now, we have this again. Let me just go through. This here is your divisor, the verb, the divisor. No, divisor is a noun. In fact, all three are nouns, but divisor implies that it is doing something. So the divisor is the thing that is dividing. The dividend is the thing that you are dividing into. So you divide the divisor into the dividend to give you a quotient. And of course, you have a remainder here, which will be 0 if 17 is a, listen to the vocabulary now, factor of 255. So in other words, if I want to factorize 255, you hear the vocabulary, yeah? I could say that 255 is equal to 15 multiplied by 17. Alright? So in the same way, that I divided 255 by 17 and got 15, if I were to divide 255 by 15, I would get 17 on top here. So if I factorize 255, I get 15 by 17. Now of course, you look at 15 and you realize that 15 itself could also factorize. So 15 would be 3 multiplied by 5 multiplied by 17. Right? The general convention when you're doing these things is to write the smaller digits first. So instead of putting 5 by 3, I put 3 by 5 by 17. It doesn't really make a difference, but it's nice to be aware of the conventions. So just like how in the last video where we were factorizing we were factorizing 1 minus k to the power 4, and we get 1 minus k squared into 1 plus k squared. Alright? The same thing happened here. You take the original entity, you break it up into two factors, and then you realize, but wait, one of the factors here could factorize even further. The same thing happened here. So we take 1 minus k to the power 4 and we factorize it into 1 minus k squared into 1 plus k squared. You realize now that 1 minus k squared itself is factorizable. So 1 minus k squared is 1 minus k into 1 plus k, and then of course you get 1 plus k squared. So again, the same thing that happened with regular numbers happened with expressions, and it's the same thing happened here. So we're now going to do the division for the expressions to demonstrate the point that we're trying to make. Alright, so I'm just watching the time. Alright, the equipment that I'm using right now wouldn't let me record for more than about 20 minutes at a time. Alright, I will get all upgraded equipment soon so I can just put the camera and run. So I always have to be watching. The nice thing about it is that I have to chop up the videos by force, right? Which means that you wouldn't have these long videos to look at, and that is something that I will also have to keep in mind when I upgrade the equipment, because you don't want to always be going so long that it becomes difficult for people to keep the concentration going. Alright, so keep your concentration. We're just going to do one or two last things here and then round out the video. So back to our quadratics that we were working with just now. So if I have, watch it now, x squared minus 3x plus 2 divided by x minus 1. Alright? We're doing this one first. Now, when we do the division, we're looking at the x's and the powers. So x into x squared will be x. Right? We know that x by x is x squared. So x squared divided by x will give an x on top here. And then you take the x on top here and then multiply by the whole expression here. So x by x is x squared. Right? X squared. And x by minus 1 is minus x. Yeah? So, just like we would do with regular numbers, we subtract. X squared minus x squared is 0, so we leave it out. Now, here is where you have to be careful, especially when you have minus signs in the picture. Alright, so watch carefully what I'm doing with this one, with the other one, and with the other two in the next video, so that when you start to do the questions that would accompany these videos, you could have some level of awareness of possible mistakes, and we just work with it. Yeah? So minus 3 minus x. And what I always advise my students, if you need to go in a corner and write it out, write it out. So minus 3x minus x is the same thing as minus 3x plus x, which is the same thing as minus 2x. Right? Again, to move from here to here to here, if you're doing add maths, that shouldn't be a problem. If you're still having problems like with that, then you need to fix that, because it only gets more complicated from here. Right? So minus 3x minus x is the same thing as minus 3x plus x, which is minus 2x plus 2. You bring down the plus 2 from here. So x into minus 2x is, watch it now, minus 2 into x minus 1 is minus 2 by x is minus 2x, minus 2 by minus 1 is plus 2. Alright? And you see the same thing on top as on the bottom, so you know immediately that when you subtract, you get 0 at the bottom here. So you have an example here where you divided x squared minus 3x plus 2 by x minus 1, you get x minus 2, which is a nice way of saying simply that as we would have started, you know now that if you wanted to factorize this and you did it using long division, you would get that x squared minus 3x plus 2 is equal to x minus 1 into x minus 2. Alright? So even though at the level of maths you wouldn't factorize a quadratic using long division, when you get into the level, when you get to add maths now, long division is one of the methods you could use, because some of the regular methods that you would use at the level of maths will be a little too cumbersome if you try to apply them directly at the add maths level. So now I'm going to round off the video. That's 19 minutes. Okay, so I'm out of time for this video. So what I'm going to do is wrap up here. I'm going to start the next video by doing the other one, the other side of this. I will divide x squared minus 3x plus 2 by x minus 2 and verify that we get x minus 1 as the answer. And then I will go into the more complicated ones that I have here on the paper. Yeah? So we stop here for now and we continue with the next video.